So here's an example of some things you can do in MATLAB. Right now I'm just running the command line. But one thing to first think about is what's called a lin space. So linear, I'm going to take a whole bunch of elements. I'm going to go from 0 to 12, and I'm going to, let's see, I'm going to make 10 of them. So I've got values of x now running from 0 to 12 with 10 of them. I can do this, x to the second, and I can square each one of those elements. And then what I can do is I can open a new figure. I'm going to call it figure 1, and then what I'm going to do is plot x, y, and I'm going to use a red line for that. And what this does in figure 1 is plots a parabola. And what I can do, I can hit CLF to clear figure 1, and I can do this again using up to go backwards, and I can do a red line with solid dots connected there. So I can do the same thing here. Instead of doing it direct into the command line, if I want to save it, first thing I'm going to do is clear all variables, CLC to clear console, and I'm going to do, let's do a parabola, lin space from, I don't know, I'm going to go from 0 to 10, and just for fun, I'm going to have 100 different elements. I'm going to put the semicolon at the end of it so it doesn't clutter up my command line. If I don't have it there and I run the script, this is the output to it. I don't want to see all of that crap on my command line, so I'm going to use a semicolon, and now when I run it, it's made a variable x in the command line. So CLC to clear the console. And now I'm going to use y is equal to x. In MATLAB you need a dot caret to square each one of the elements in the array x. I'm going to make figure 1, I'm going to clear that figure, I'm going to plot x, y, and I'm going to use, well, let's just do a red line with some dots on it. We'll see what that does. I run that. And here's my line with dots associated with it. I forgot to suppress y equals x squared, so I'm going to go back, run it with that suppress, and I come up with the same graph. Let's put some labels on it. X and a y label. And then if I run that, I've got variables for x and y. I can do things like this, axis square, if I want to have a nice square axis on it. And then what I can do is I can go edit, copy figure, and I can paste that into my Word document or whatever I'm going to do. And it's just going to be easier if I go edit, copy figure, and now I can paste it into here. It just looks cleaner than trying to do a screenshot, so you can put that right into your document. There's a few other things we could do. Let's do what's called a looping. I'm going to make a loop real quick. And I'm going to say for I equals 1 to 100. So I've got 100 different locations in x. I'm going to say y I is equal, or here, for I, I'm going to use a variable I. For y, and then yi is going to be equal to xi to the second power. So I can do the same thing this way. And then if I run through it, it makes the graph again. I'm going to suppress that. If I come back, I get the same plot when I run it. So now what I can do is I can put an if statement in here, and I can say if xi is greater than 5, I'm going to call yi, let's just set it equal to, I don't know, 10. And then, so I'm going to end that if statement. And then here, well actually, let's do else. Else yi is equal to xi to the second power. So I'm going to delete this row up here. And then I'm going to end that if statement. And when I run that, this is what I'm left with. So it runs through every value of x. If it's bigger than 5, we're going to set it to 10. Otherwise, we're going to make the parabola.